All right, welcome to this video here where we're going to be taking a look at how do we remove a division statement, which can also be seen as a coefficient in some ways, but we're going to look at how do we remove a division statement in a linear function. A one-step linear function happens to be, we're just going to look at one-step linear functions where we only have a single thing that needs to be removed from the variable in order to determine what that variable answer is. Many of these we could take a look at and understand without doing the calculations. Okay, so in this case here, what value divided by 4 gives us 3? Well, it's got to be 12, right? 12 divided by 4 is 3. But how do we get there mathematically? Mathematically, we want to remove all numbers away from our variable, and we do that using what we often consider as the opposite operation. If we divide something by 4, to get it back, we have to multiply that same thing by 4. So if we divide by 4, then multiply by 4, it actually cancels out that process. The thing is, if we multiply one piece by 4, we have to multiply everything by 4. And so in this case here, we're going to multiply both of our terms by 4. When we do that, the v gets left by itself, and the 3 gets multiplied by 4 to become 12. And so therefore our v value, there we go, tongue twister, has to be 12. Let's look at another one. We might see something where we have this division using a fraction, which is very much like a coefficient. It's just a coefficient of a fraction, or in this case here, 1 over 6. When we do this, there we go, our answer should be 21, but how do we get that? Well, the same thing applies here when we have a denominator or a fraction. So in this case here, a denominator that is underneath a variable. To get rid of that denominator, we want to multiply by that same number. The divide by 6 and multiply by 6 is going to cancel each other out to leave us with just x. And then when we multiply every term by 6, we're going to get that our x value has to be 21. Very important again that we multiply every term by 6. In this case here, there's only the 2, but we have to make sure we get that. If we have multiple fractions, we may want to multiply by a common denominator, okay, which could help to clean things up a little bit, but that's something for another video, a later time when we do have multiple fractions. I hope this has helped you out. Thank you so much for watching. Have a wonderful rest of the day.